to the In-Building Tech webinar presentation, How to Bring 5G in Building. Prior to introducing our esteemed panel of speakers today, I'd like to request everybody that if they do have any questions for our panel, please feel free to submit them via the Q&A link, and we will discuss them during the Q&A session at the end. Today's webinar speakers are Mr. Hongtao Zhan, who is a self-made entrepreneur and CEO and co-founder of SureCall. SureCall is a manufacturer of 5G antenna and signal booster in-building equipment, and SureCall remains at the forefront of 5G development and was among the first to release a 5G in-building signal booster. We are also joined today by Mr. Nick Marshall, who has 35 years of experience in the wireless industry. Mr. Marshall is the research director at ABI Research, and he manages ABI's wireless research's coverage on radio access network infrastructure, including topics such as macro base stations, small cells, enterprise and consumer FETMO cells, in-building wireless systems, as well as low-power wide area network solutions for IoT. And I am Urvashi Verma, the technology editor for In-Building Tech. I will be sharing some insights in regards to the commercial real estate sector, and then we will move on to Mr. Zhang and Mr. Marshall, who will share with you the technical aspects of bringing 5G in building. So what we see happening in the commercial real estate sector is really that there's been a shift. Obviously, within the last 15 to 20 years, digital connectivity has now become the fourth utility. With 80% of mobile data consumed indoors, occupant demand for transmission and employee workplace connectivity is becoming paramount to create tenants. When we look at cellular signal performance, it's driving tenant decision-making in the commercial real estate sector, as far as commercial office leasing, as well as enterprise leasing trends are concerned. And smart building technologies, IoT applications are also requiring 5G connectivity in the near future. Firms like JLL, Newmark, Knight Frank, the Meridian Capital Group, and many others are really now looking at the building in a very different way than they were previously. Providing an enhanced occupant experience is most important, both to their ROI as well as keeping their occupants comfortable, and enabling their tenants, who are often large enterprises, enabling their employees to be most productive at work. These major trends are really driving the change in the marketplace and demand for connectivity. When we look at the adoption of IoT and how that's driving demand for 5G in the in-building enterprise markets, it's clear that enterprises' use of bring your own devices, cloud-based systems, and other mobile device use is fueling growth for greater data management, network bandwidth management, remote monitoring, and security. Enterprise, whether it's an enterprise that's building a space or a premise for itself, or they're trying to lease a space within the commercial real estate sector, they will certainly need this type of connectivity in the near future. The commercial real estate sector also has had some shifts that have taken place. So previously, decision-making at the top of the funnel was the building owner. Now, with the interest in competition is basically driving talent for workforce and millennials and occupants to the top of the pyramid. So today, more than ever, it's the occupant that is actually driving the decision-making that's being made by the building owner. We see that CRE tenants today are demanding digitally connected workspaces that drive workplace productivity and occupant comfort, like we've mentioned. And owners are now having to adapt to these changes in the workforce as well as the technology. Just so today, the way building owners are really able to monetize their assets is by looking at what their occupants are doing, how the occupants are using the building, how it is that they can engage them to be more comfortable, how it is that they can engage them to be more productive. And at the core of all of that is a digital connectivity infrastructure that's going to enable them to do that. So this new decision-making model with the occupant on top is actually really going to drive greater adoption for digital connectivity. And then lastly, we have the 5G evolution, smart buildings to integrated intelligent ecosystems. And currently, smart buildings, the majority of commercial real estate sector we see is equipped with sensors. There may have different systems that are currently siloed. So for example, the lighting system, there may be a security system, and they're not yet integrated. As more commercial real estate owners and buildings move towards a more integrated system and of what we call a digital twin, essentially, where all the disparate systems work together, the building works more efficiently. It drives then better outcomes for owners as well as occupants. We are now going. This is sort of the phase where we are right now. But in the next 5 to 7 years, the big shift that's going to happen with 5G is that it's going to enable these smart buildings now to integrate with the larger ecosystem of the smart city. And whether that's connecting to the traffic lights, to energy grids, and to other municipal systems. And so 5G is really going to play a very significant role in enabling that in the future as it builds out and as more applications emerge. So that was my brief summary of the commercial real estate sector and how 5G will have impacted it. I'd like to turn it over now to Mr. Zhan, who will discuss with you. Yes, Mr. Zhan will discuss with you bringing 5G indoors.
Thank you, Urvashi. Yes, as everybody here probably know, bring the cellular signal inside the building is extremely important. Inside the building, that's where 80% of the cellular communication happens, not outside, 80%. So even for wireless carriers, this is extremely important. This is, ballpark of your market. So let's talk about it today. Thank you, everyone. Next. So here I'm giving a small introduction about SureCall. Our company is founded 2001. This is 18 years on, and we are singly focused in signal booster market. 2G, 3G, 4G, 5G, you name it. We're in this space. We're always about buildings. Of course, we're also cover the cars, but that's a smaller market. We have a DNA of innovation. We have a lot of important patents in this space, and SureCall been blessed. Also happened to be very successful during the last 10 years period of time. We have been Inc. 5,000 company for 3 years in a row. Last 3 years, we're very proud of that, and we also win CES Innovation Award in 2017. One of our boosters. I think we shouldn't win. We did win. There was another one I think we should win, but we didn't. Anyhow, so we got that, and we also one of the top 100 fastest growing companies in Silicon Valley 2 years in a row. We're proud of all that. And next. Oh. So let me start the 5G discussion by showing everybody a graph of the prediction. The 5G connection will happen. It's not a surprise to anybody, right? It will happen by 2025. Roughly half of all the connections in the United States will be 5G. Globally, like always, it will be slower. The adoption will be slower, but it will happen eventually. In 20 years later, everything will be 5G, maybe even going 6G. We don't know, but this is happening. It's happening right now. And we are at the start of a revolution. So it's an exciting time for the people in the industry, for the building owners, for carriers, for everybody. Next. However, there's a huge challenges that's bring the 5G signal inside the building. And unfortunately, this is just a physics. Nobody can do nothing about it. Typically, 95% of a 5G frequency bands at the 6 gigahertz or above. At that frequency, especially 28 gigahertz or 39 gigahertz, the building penetration will be at least 100 times worse compared to the 4G right now. It's not linear. It's not linear. It's going to be horrible. I know for sure something has to be done to bring the 5G signal inside the building, pretty much for every single building. So this is not like a 4G anymore. It's challenging. It's going to cost the whole world a ton of money, billions of dollars of money to get this problem solved. Well, at the end of the day, after billions of dollars, you will have 5G signal everywhere. We're talking about a gigabit per second on your cell phones anywhere, everywhere. So it's going to take a while, but it will happen, and that's just the trend. Next. So to start with, I think people in the industry will know a perfect coverage, perfect cellular coverage inside a building. It's hard. It's hard. It's really hard. As for the last 10 plus years, the whole industry trying to provide coverage for the building for everywhere, for LTEs, WCDMAs, CDMAs, you name it. And still it's probably 13% of the building are still having problems. I would actually think it could be a lot higher, the percentage-wise. But anyhow, so that's just a reality. It's a difficult, typically difficult last mile problems, especially when we're talking about wireless connections. When 5G comes, that's going to be 95%. So it's hard, and it's always be hard. It will never get to the perfection, and it's a good and bad for the industry. And then let's talk about FR1, FR2 next. It's important for everybody here to know the name, get some ideas, because you will see this happens all the time. So FR1 typically referring to the frequency that's the spectrum that's below 6 gigahertz. The FR2 is the opposite, above 6 gigahertz. FR2 typically we're also referring to millimeter wave because the wavelength is much shorter, and FR2 it's easier because of the wavelength is the frequency is lower, the wavelength is longer, because the physics, the building penetration is a lot better, but still, you got probably 20-30% of building has problems. For maybe the signal is too weak outside, maybe the building materials are too strong, too thick, low E glass, all that doesn't help. Anyhow, so those are the challenges, and obviously there are solutions, on the market. Fundal cell being a solution, one of them. That's been one of them. Signal booster, which we're working on, is another solution. In my opinion, signal booster is, by far the preferred solution, for at least two good reasons. Number one, it does not require internet connection, separate internet connection. No, signal booster is the only solution that's stand on its own. You can go 100% wireless. You don't even need ISP anymore. You don't need an internet connection. You can just go 5G and 5G only. You can get rid of all the other bills. Consolidate your bills into one, and it's least expensive out of all. So next. Yeah, let's talk about the 5G challenge. What are the difficulties, to build out the solutions, be it DAS, fundal cell, or signal boosters. The first solution, I think as an engineer, as the TDD was FDD. This is getting, technical complicated. The simple explanation is that, in the United States, in the LTE world, most of the frequency, AT&T, Verizon, T-Mobile is using FDD, meaning the uplink and the downlink are using separate channels, separate frequency band. When you're talking, you're using one. When you're hearing from the other party, you're using a different one, and then those two completely separate bands, and that's FDD, right? TDD is the opposite. You're sharing the same frequency spectrum. You're switching, dynamically very fast. Like it or not, 5G goes TDD. So every single, technical company in the space has to solve this problem, first. And it's a problem can be solved, but it's not an easy problem, to solve to begin with. Okay. And in case I haven't confused you, there's more.
Mr. Zhang, we have a question from the audience that I think it's important to answer it now.
Sure.
Can boosters be used for TDD?
The answer is yes, definitely yes. Obviously, you're not going to be able to use the old, LTE boosters. New booster has to be developed, and but it can be done. I actually predict, the TDD booster probably will be out, next year, sometime next year, maybe later next year. Yes, definitely it can be done. Does that answer the question?
Yes, thank you.
You're welcome. So the next technical challenging is the MIMO and the beamforming. You guys might heard of, right? Everybody's talking about MIMO, beamforming, beam steering, beam this, beam that. This is all about antennas. And with MIMO beamforming, you can get extremely high gain antennas. not only you get a high gain antennas, and this, the direction can be electrically moving around and tracing the end users. So it's super duper high tech. It's amazing. That's with 5G. That's happening. So for every single booster company, femtocell companies, I'm talking about equipment manufacturer. They all, we better all figure it out and make it happen, because that's what part of the 5G is about. It's very complicated, but I believe all this will happen to the signal booster industry as well as DAS and femtocell. Thank you. Next slide. Next, I'm going to talk a little bit about cable loss. I think a lot of people here, especially installers, people in the industry, should know about the cable loss. The only difference is that in the 5G world, the cable loss will be 10x bigger. Give you an example. For RD6, 100 feet RD6 at 28 gigahertz, the loss is 44 dB. 88 dBs, and which is crazy. Crazy high. Something has to be done, to overcome that. Different, technology exists, but it's crazy. For installer, you got to remember that that's a problem. Only going to get worse, and that's part of the thing to make the 5G system, deployments challenging. You got to be very careful with the connectors, cables, everything. It's not the 4G anymore. LTE, look like kids game in the 5G world. But it all can be done. The problem all can be solved, and I think 5G will happen, and it's going to be wonderful. Next. Okay, let's talk a little bit about exactly what the 5G booster is going to look like. It's going to feel like, exactly what you're going to expect, right? You cannot get this anywhere else, and I'm the first to tell you, mark that. So, for the boosters, 5G boosters, there will be window mounting option. If you go to SureCall website, SureCall.com, one of the product we have is called Easy 4G. That's the first one, on top, the graphic. You can say, you mount that thing on the window, and you get the signal inside. There's no installation requirement. The similar thing will happen with 5G, right? Similar form. It will be different form factor, but the way it works will be similar. So the window mount option is still there. If you're lucky enough, you get a plenty signal on the window, that will still be there. So, another big thing is the ERT technology will be needed. SureCall patented the ERT technology, and fundamentally is saying, you have to, get a booster to the top of your car or buildings, for that matter. That's obvious, right? Somehow you have to take care of the cable loss. That's what the ERT is about. It has to, happen. I predict. And an example of that is our product named N-Range. You can see that it's a it's a technology. You integrate your antenna with your booster and then put everything in an IP67 waterproof box, put on top of your car or the buildings. So that's that's ERT. And of course it's a lot more complicated than that, and but that's the that's the basic concept of it. From always say 5G is going to cost the whole world a ton of money. I'm talking about billions of dollars, almost too expensive, to do it. That's why it might take 20 years. Not because of technology, a lot of it is because it's expensive, extremely expensive, even for wireless carriers. That's why the low-cost solution become a key. You just couldn't afford it. Think about it, guys, right? Every single building pretty much need a solution, and the 5G signal will not come into buildings by itself. I can guarantee you that. So keep all that in mind. So that's why signal booster become critically important, not for the whole industry, for the whole ecosystem, because it's unique, it's low cost, it does not require backhaul connectivities for all that. Next.
Mr. Zhang, we have a few questions that
Yes.
come in. Would it be all right if I
Yeah.
ask? Okay. So
Before I go there, sorry, I think there's one more thing I have to mention. SureCall happens to be the first company come up with 5G signal boosters. Somewhere, I think we didn't mention that, and the product name is the Force 8. Force 8. So this is FR1 booster. Nevertheless, it's the first and the only signal booster that's 5G ready, and you probably can buy one somewhere, Q2. So Q2 this year, and that's the harbinger of the 5G boosters, and Force 8. That's the name. We're so proud. We announced it at CES this year, and we're working on 5G. Sorry, Urvashi, and let's talk about all the questions.
Sure. So we have Ms. Casey Garrigan, and they're asking, what comments do you have regarding Wi-Fi cellular convergence to complement 5G in building?
Yes. Oh my gosh, convergence. We have spent a lot of money, R&D, trying to convert this thing for 5 years. So far, we haven't been successful. It's a wonderful theory. Somehow, it seems the Wi-Fi industry and the cellular industry, they just, they're like oil and the water. They sometimes they don't. You just couldn't mix them up. We tried. Actually, you know what? I think it's a fight. They're competing. On the one hand, Wi-Fi is cheap, right? Wi-Fi is cheap. But Wi-Fi is unlicensed band. Compared to cellular, Wi-Fi is less secure. less reliable, right? You don't have guaranteed service, right? Cellular, on the other hand, it's expensive because, the spectrum is licensed, right? Verizon, AT&T has to pay billions of dollars for those, for those spectrum and to begin with. So it's expensive, but it's secured. It's guaranteed, because you're paying for access, so I'm actually thinking, because of 5G, the cellular could win out, meaning like, 10 years down the road, 20 years down the road, you probably don't need a Wi-Fi anymore, right? All you need is a cellular because, you have plenty of bandwidth. If the price is cheap enough, if you have the signal everywhere, why you need a Wi-Fi? That's just a message. Does that answer the question?
Yes, thank you.
Okay. I think.
So were there, I think that what we'll do next is we'll hear from the research director, Mr. Nick Marshall of ABI Research, and he'll be sharing his insights in terms of the marketplace with us. So Mr. Marshall, you ready?
Yes, Urvashi, thank you. Can you hear me?
Yes.
Okay, so next slide. And so what I thought I'd do today is take a high-level view and discuss the major trends in 2 or 3 slides, and it's concerning the evolution of the radio access network as it applies to in-building systems. So I wanted to talk about trends, and the main trend or theme I would like to get across today is convergence. In the past, networks were built for coverage, using macro towers, cell towers that we all see all over the cities and countryside, and that rapidly moved. Once coverage was obtained, that moved to a mode of densification, including in-building with boosters, dash systems, small cells, and Wi-Fi. That's kind of where we are at today. But now in the future, we're moving towards convergence, both in the architecture of the RAN inside the building and with the technologies available to perform in-building wireless. And the last thing I wanted to do in this short presentation is to pull this all together in a kind of a roadmap, something we call an event horizon or transformative horizon. So next slide. Okay, just for those who may not know ABI Research, just a few quick words. I don't want to take up too much time, but as you can see there, we're a forecasting and consulting market research company, producing presentations like this one, custom research reports, forecasts, market data, and insights, and we have about 17 different services. Looking at technologies ranging from mobile network infrastructure to AI, machine learning, smart cities, IoT, industrial, and so on. So if you don't know us, please check us out on the web. Next slide. Okay, so I'm trying to present here the architecture convergence. This is technology convergence. So, and the technologies are converging in 3 spectrum types, unlicensed, technologies like Wi-Fi 5 or Wi-Fi 6, upcoming multifier, and even 5G in unlicensed is under consideration. Licensed spectrum, of course, is what we're all familiar with, 3G and 4G LTE. Now it's 5G and also the IoT protocols such as NB-IoT and LTE-M. There is a move now to share the precious spectrum resource, and there are shared spectrum schemes coming. You may have heard of CBRS or ONGO, and even 5G has been proposed to work in shared spectrum. So what I wanted to say is that as Hong was saying, to get a good signal and fast throughput that we all want inside a building, you need a very good signal to noise ratio inside the building, so that you can get high order modulation, get the throughput, and liberate network resources. So that's very important, and that does dictate that signal source moves indoors, both for LTE and obviously 5G. 5G also requires an LTE network underpinning it. 5G operates in a dual connectivity mode, where if you walk out of range of the 5G signal, you hand over to a 4G signal. And we also mentioned millimeter wave spectrum. That's going to be deployed, we think, in controlled and physically limited environments where very high throughput is required, such as in conference rooms in an enterprise. So those are the technologies coming down. Next slide. I think we skipped a slide, Urvashi. Go back to one more. That's it. Okay, thank you. Then RAN architecture is also converging. We talked about signal boosters, repeaters, and also including that small cells, where the baseband, the radio, and the antenna are distributed throughout the building. We've also mentioned DAS, or distributed antenna systems, where it's the antenna which is distributed throughout the building, and the baseband is centralized in a telecom closet in the building. There is a move now to converge these into a distributed radio system, where still keeping the baseband centralized in the building, a radio and antenna are distributed. This is a benefit of lowering cost, and therefore in building wireless becomes more economical in smaller floor areas like the 100,000 to 500,000 square feet building. Also leveraging virtualization, the RAN, the baseband can move to commercial off-the-shelf equipment, servers. In data centers, the data center can either be in the building or be a regional data center. This frees up space in the building for compute, storage, and networking, which can be disaggregated back into the building for ultra low latency applications. There are many opportunities here for OEMs and system integrators, system builders, and VARs. So very quick convergence discussion. Next slide, please. No, the last slide, I should say. That's it. Yeah, here we have what we're calling an event horizon. And the way to read this is the top row is a pessimistic kind of forecast where things take longer to introduce than planned. The middle row is the most likely forecast of when these technologies occur, and the bottom row is an aggressive, very optimistic forecast. So I'd like to just concentrate on the middle row, the most likely scenario first, and we believe this scenario is holding up today. Today we have license-assisted access technologies. We have CBRS almost there. This year, next month, we have the IoT technologies also available. Within 12 to 18 months, we're going to see multi-fire, which is LTE and unlicensed spectrum, private LTE, cloud RAN inside the building, multi-access edge computing in the building, public safety. We're going to see low-band 5G in the building. That's sub 1 gigahertz. And then moving further out, we can see vRAN or virtualized RAN coming. We see mid-band 5G, that would be 3.5 gigahertz coming out. And then within 3 years, millimeter wave inside the building. And the ultimate goal is to end up with a fully converged multi-technology in-building RAN operating over licensed, unlicensed, and shared spectrum. It's quite a roadmap. It's quite complex, but I hope you find that helpful in your planning and or instructive. And that's all I wanted to cover. And with that, thanks for listening, and I'll hand back to Urvashi. Thank you.
Thank you, Mr. Marshall. That was very insightful, and we did have a number of questions that came in. So we wanted to start with we will now formally begin the Q&A session. I know that we did respond to some of the questions as they were coming up earlier, and we will try to get through everybody's questions as best we can. Mr. Marshall, I think this question will propose for you perhaps, is that we are seeing right now in the industry, there's a lot of buzz and interest in private LTE and CBRS. How do you think that the marriage of the two is going to impact the ecosystem and the wireless ecosystem? If you could talk to that, it would be.
Yes, thanks, Urvashi. Yeah, absolutely. Private LTE is very definitely an important trend, and it's linked to CBRS, where you can, without spending millions of dollars on a spectrum license, you can obtain the right to broadcast over or to build a network on the CBRS frequencies, which is 0.55 to 3.7 gigahertz, purely by subscribing to a service, a spectrum access service, an SAS. And there are several companies building that right now. So as a building owner, you can buy the equipment. You register it with an SAS provider and start operating a network. And you can do that either as a totally private system for your building, where you may be concerned about security or confidentiality, and you can air gap that network from the public networks. You can arrange to operate it jointly with a licensed service provider, and so very much it's a trend that's coming. Also, CBRS right now is TD-LTE, so it can provide IoT using NB-IoT and LTE-M technologies. So you may be concerned in a manufacturing building about, sensing, or video surveillance or autonomous guided vehicle control, that kind of thing. So very definitely an important trend. I hope that answered the question.
Yes, thank you. Sorry about that. I was having a little trouble unmuting myself just now. The next question is for you, Mr. Zhang. They wanted, one of our audience members wanted you to discuss a little bit more about how will IoT 5G impact IoT connectivity, and if you can relate it to the in-building wireless market, that would be great. But in general, what is your overall thoughts on IoT connectivity and 5G?
Sure. People always saying IoT, 5G. In my opinion, they're distance away. They're two totally separate things, almost. And they're IoT typically very low bandwidth, low cost, low bandwidth. We're talking about a couple kilobytes per month, kind of reading a meter kind of application. The 5G network is the opposite, right? So we're talking about gigabits per second, right? And as I just explained in my presentation, 5G is not going to provide better coverage. It's the opposite. 5G's coverage of 5G is going to be horrible, and unless you spend a ton of money to solve that problem, it's not going to provide you with most reliable connectivity. So wake up, guys. That's the reality. That's the physics. Nobody can change that. I wish it's the opposite. So unless something dramatically changed, someone, invented some IoT application, which is the bandwidth dense, that the two things are irrelevant in my opinion, actually. So, don't listen to the media, don't listen to the people who, confuse you more. So, the two things are distance away, separate concepts, totally. Thank you.
Great, thank you for that. The next question is from Mr. Marshall. This is from Dwight McRae. He's wondering, what killer use cases do you see 3GPP release 15 and coming release 16 enabling?
I'm sorry. Okay, so that. Oh. Sorry.
Should I repeat the question?
I think,
yeah.
Let me repeat it, Urvashi. I think the question is what killer use cases are coming out of 3GPP release 15, which is the first 5G specification, and the forthcoming release 16. So we believe here at ABI that the first killer use case is enhanced mobile broadband from release 15, and even there is a pre-standard system run by Verizon called 5G TF, used for fixed wireless access as a kind of wireless cable for buildings. So yeah, it's ENBB, and then what we are going to see is once we have compute network and storage at the edge of the network inside the building, say we're going to get ultra reliable and low latency communication services such as what you might require if you are controlling a remote vehicle, say in a shipping port or something. And in parallel, we're going to see machine type communications, IoT, massive IoT connections rolling out. So those are the three, and that's in line with the industry. That's in line with the ITU vision. I think enhanced mobile broadband first, then followed by URLLC and NB+C. Thank you.
Great, thank you. And we have a few other questions. I think we will be wrapping up shortly. So if you do have any last minute questions, I'd certainly suggest that you start submitting them now. Seems like there's a lot of interest in our audience base regarding 5G Wi-Fi convergence. So we see this question coming up. And I would like to get your perspective on it as well, Mr. Marshall. I know that Mr. Zhan has shared his views. What is, from our attendee here, what is the ideal view of 5G Wi-Fi convergence from the perspective of the RF node, digital unit, and packet core? So can you talk a little bit to that?
Okay. Yeah, absolutely. That's a great question. And, Wi-Fi is important. We all have it everywhere. It's in the handsets, in the laptop. However, Mr. Zhan was perfectly correct. It operates in unlicensed spectrum, so your access to the network is on a best effort basis. And I'm sure we've all noticed that in a conference, for instance, once the attendees start to pour in, your Wi-Fi connection gets slow. That's because it operates on a kind of listen before talk basis. If the system, the handset, will listen to the radio channel. If there's no traffic, then it will use it. If there is traffic, then it'll back off, wait a random period of time, and try again. So with very many users trying to access, Wi-Fi ends up being congested. Unlike any cellular, which is a scheduled access to the network, the terminal has a time when it knows it can broadcast without interference and make best use of the spectrum resources, so it doesn't congest as quickly as Wi-Fi. Now, the latest upcoming version of Wi-Fi will change that. It's called Wi-Fi 6, and it's becoming more cellular-like in its access mechanisms. It's got a scheduler in it, so as I understand it, and so the Wi-Fi terminal now knows when to broadcast in free air without congestion, and so it will not bogged down. And so we think with the new Wi-Fi 6 and cellular, either 4G or 3G or 5G, there's a place for both. Because we can expect to see, just as we have today, Wi-Fi 6 radios inside every handset, inside every laptop. So yeah, I think there is also one last point. There is a move between the Wi-Fi Alliance and 3GPP to somehow combine Wi-Fi and cellular for the future, for Wi-Fi offload by MNOs and so on. So it's another example of the convergence trends I was talking about. We think there's a place for both Wi-Fi and 5G in the building in the future. Thanks.
Great, thank you very much. And like I mentioned, we will be wrapping up soon. We do have a couple of other questions that have come in, and one is in regards to the I believe this is from Mr. Dwight McGray, and it's obviously you're a prop tech consultant advisor to Enterprise ICT investments from REITs. And this is related to the commercial real estate sector. I think I will try to address it and then have our panelists answer your question as well. And I believe, your question is, my educated belief is to proposition wireless connectivity packaged with a more comprehensive value proposition, considering IoT and building automation. What are your thoughts? I mean, absolutely, from my opinion, somebody who writes about this topic, I think that there's a massive piece of the conversation that's often missing when it comes to smart building technology. And that is talking about what is the underlying connectivity, digital connectivity structure that either exists within the client's ecosystem. And oftentimes I write about a lot of prop tech firms and interview them. And I always find that they're often not having that discussion at the forefront. For them, it's about their technology, but what's actually going to enable their technology and how good of a fit it's going to be for a particular client or not. A lot of that also drives with the infrastructure that they have. So I think that there could be a better job done in regards to that. And then I'd like to turn it over to both of our panelists to talk about that, and if they had any thoughts about that. Mr. Marshall or Mr. Zhang, did you have any thoughts about that, about the technologies, smart building technologies that are actually going into buildings? How often are you seeing a discussion about the underlying digital connectivity from that?
Yeah, this is Nick here. Absolutely, I think it's a value proposition that's a use case that's becoming more popular as these technologies become available, such as NB-IoT and LTE-M, bundled with the network inside the building. The basic voice and data access is one thing. For a building owner, it can enhance the value of the building, but controlling building automation, controlling lights, heating, can save a lot of money. A fully smart building can be quite an economical proposition. I think also video surveillance, that kind of thing, can all be done. Those are, I think, some of the things that make us attractive to the building owner.
Yes, absolutely. And just to follow up on that, I do wanted to add that the four basic elements that we look at in the trends today that are happening in the commercial real estate tech sector. It's about driving ROI, which is through tenancy, and nowadays more than ever, the majority of the smart building applications are using technologies like artificial intelligence. Massive amounts of data is being collected in smart buildings today, and that is actually being used for building owners to be able to monetize their assets. So, I would say one of the bigger value propositions is not just the information that's surrounding the better management and efficiency of the buildings themselves, but also around the data that will be collected regarding the occupants and and how you're able to then monetize that as well. So I think that's also one of the emerging value propositions.
Okay, can I add a few things on this one? Okay, so I would give out two answers. 2 points. So first one is it's all about education. The developer, those people they're not electrical engineers. They don't necessarily understand this. It takes time to educate those people. Say, exactly as you said, right? This is a force utility. You got to have other three, and this one you got to have the two. But the whole world is not there yet, right? The whole world is getting there. So education is critical to the general public, to the developers, to all the people that's, in the system, should be in the system. Secondly, I predict the 5G is a game changer, a game changer. when the 2G, 3G, 4G happens, actually, the whole world, the carrier has a free ride, because the signal automatically penetrated through, 80% of the buildings. You don't have, for the 20% of buildings, that's where that signal booster, have, industry rely on those, solving those problems, 20%. But when 5G happens, which is as my presentation, showed, we're talking about 95% of the building will have problems, right? No 5G signal, millimeter wave signal can penetrate inside the building. So, it has to happen. So, 20 years down the road, it could be that this false utility, right? Whether you have 5G millimeter wave signal inside the building or not, differentiate the first word was the third word, right? Like, today, if you're into a country, into a building, you don't have, electricity runs into your building, then you're not the first word, right? You're third word, right? And maybe 20 years later, if you don't have a 5G connectivity inside your building, you're not the first word, right? We as a country, United States, we better be the first word, right? So you better have 5G coverage, the false utility in every single building, right? I hope there will not be a 5G divider, in this country, but I think it will, because this is going to cost a lot of money. So that's answer the question.
Yes, thank you. And with that, I think we are going to wrap up our discussion for today. Again, I'd like to thank very much the audience for your participation, and thank you to our panel and panelists, Mr. Zhan and Mr. Marshall, for joining us. If you have any other further questions, feel free to send us emails, and we'll be happy to get back in touch with you if there's anything else that you'd like to follow up with in regards to.